Viewers, welcome to Science Spectrum with Don. This is the 10th part of the special third lecture in measurements of physical quantities. And of course, so far, we've been talking about the various instruments we use for measuring length in the laboratory, and of course with the direct method. So far, we've talked about how we measure length with the vernier caliper. We talked about how we correct for zero errors, which could be negative or positive errors. Now, we are onto the micrometer screw gauge. And of course, in the previous class, I said it just, this works with the principle of fitting an accurately, finely threaded screw to a nut. So I'll proceed from where I stopped. So this is a screw. So this is a screw. So this is a screw. So a finely threaded screw. We are fitting it to, okay, this nut. Alright. Fitting it to the nuts, just like so. Alright. And of course, this is what I call the stud. You could fit an object, okay, in this stud. And with the help of the ratchets, I could, okay, rotate this back and forth. So I could screw this, and this may go forward, and I could unscrew it, and it may go backward, right? But then I also have this frame, a metallic frame, like so, right? Then I have a linear scale here, and I will tell us about this shortly. It has some markings here, and of course I have a circular scale. So this is just the frame. This is the frame. This is what we call the linear or pitch scale. At times, this is called the main scale. Then this is what we call the circular scale. This is the circular scale. This is the circular scale. And of course, I have a screw here, which we call the ratchet screw. The ratchet screw. Of course, you could call this the stud, right? You could place an object in between the studs, or we call this the anvil, and we call this the spindle. That's for the nut here and for the nut here. All right. So let's proceed. Okay. The micrometer screw gauge. When you rotate the screw, right, across the nut once it's rotated once, either back, right, either clockwise or counterclockwise. So once you rotate the screw, okay, across the nut, either clockwise or counterclockwise, the screw, the thread of the screw, okay, would advance a distance. That distance, we call it the pitch distance, okay? So it could advance either by 1 millimeter when you rotate the screw once, either forward or backward. It could, this thread, okay, the pitch distance could be 1 millimeter or 0.5 millimeter. And we could really see that from the linear scale, right? Okay. So this we call the pitch distance. This we call, this interval, we call the pitch distance, So the screw will either advance back or forth, okay, by either 1 millimeter or 0.5 millimeter when you rotate, okay, the screw, either clockwise or counterclockwise once. All right, now, this is the linear scale where we can really see, okay, on this scale, that's advancing, that's the movement back and forth, okay, of the screw. We can really see that here, right? Okay, now, the micrometer screw gauge has an accuracy, which we also call the least count. It is simply the pitch distance, okay, divided by the circumference, of the circular scale, Now, the pitch distance could be 1 millimeter or 0.5 millimeter, right? But the circumference scale, okay, there are times you could have 50 divisions on the circular scale, and there are times you could have 100 divisions. Now, if you rotate the screw once, either back and forth, and the pitch distance, let me rewrite this, the least count, and the pitch distance, okay, advances by 0.5 millimeter, this simply means that the circular scale has 50 divisions. It's a given. And if the pitch distance, okay, did advance by 1 millimeter, it means there are 100 divisions on the circular scale. So there are 100 divisions here. And of course, if we divide through, right, this will be 5 out of 500, right? So this is the same as saying 1 out of 100, just like we have here, right? So can you see that they are the same? 1 out of 100, and this is a millimeter. So this will give us, 0.01 millimeter, right? And of course, if we translate this to, if we convert to centimeter, this will be the same as 0.001 centimeter. So this is the least count on the micrometer screw gauge. The pitch distance, if it's 0.5, you have 50 divisions on the circular scale, and if it's 1 millimeter, you have 100 divisions there. And of course, when you divide, you get 0.01 millimeter or 0.001 centimeter. All right, now how do we really measure with the micrometer screw gauge? Just a quick one. Now, the micrometer screw gauge measures to this accuracy. So it could be used to measure just the outer diameters of round objects. And of course, the thickness, it could also be used for measuring the thickness of very thin objects. Take, for example, the thickness of a wire or even a piece of paper. All right, so the object will be placed in between the stud, right? And I could screw the ratchet, right? Either clockwise or counterclockwise, okay, until the object is held firmly. And I could read out, okay, the value on the main, that's on the linear scale, which we call the main scale. And also, I could mark, okay, the value, okay, on the circular scale that matches with this reference line. And of course, I could tell what the size or the diameter of the object is. So, straight to the point now, I've established the facts, what least count is, okay, what the value in millimeter and centimeter would amount to. So, I'm going to rub this off. All right. Now, if I have, let's say I have a scale like so. So this is the linear scale you see here now. Then I have the circular scale, right? You see here. This is the circular scale. Okay? This is the linear or the main scale, the circular scale. All right. Now, if, okay, I've adjusted the screw and the object is held tightly or firmly between the stud, and let's say I have some markings here, okay? I have some markings here, and let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, okay? Let's say this is 13 millimeter. This is 13 millimeter, for example. That's on the linear scale, okay, which will account for, okay, the pitch distance. Then, let's say the 30th division on the vernier scale, okay, that's on the circular scale, so to speak, okay, matches with the reference line here. What will be the reading on the micrometer screw gauge? It is simply the linear scale, that is just the same formula, okay, the linear scale value, right, before this, okay, mark, plus the circular scale value that aligns with this reference line, in this case is 30, then we multiply by the least count. That is how we get it done. So this is the 13 millimeter plus the 30th division, then times the least count. If since the scale is in millimeter, I'll multiply this by 0.01 millimeter. And if it had been in centimeter, of course, you know, it will be multiplied by 0.001. And of course, I could give the answer. The answer is a quick one. The answer would be, I have 30 times, so this is 30 this time now. This is 30 times 10 to the power minus 2 millimeter. That means the decimal point will go 1, 2, so I have 0.30 millimeter out of this term. Then I am adding that to 13 millimeter. And of course, this will be 13.00 2 decimal millimeter plus this is point, okay? So I have 0.3, so this would be 13.30 millimeter. That is the value, okay? That's the thickness of the thin object or the outer diameter, okay, of the round object I have measured with the micrometer screw gauge. Now there are errors we encounter, okay, when we use the micrometer screw gauge. Now, the errors, okay, could be, you may need to beam this for a while. The errors could be, okay, the positive 0 error or the negative 0 error. And we also what we call the backlash error. So I will talk about each of them, okay, in a moment. So let's proceed. Now, if I have the linear scale, and let's say this is the circular scale, and it has some markings here, Now, let's say this is the 0 mark on the linear scale. That is if this ratchet, okay, this stud is joined to each other. There is no object in between. These 2 points are closed, okay? Now, if you figure out that this is the 0, right? And let's say this is the 5th division, okay, on the circular scale aligns with this reference line. This straight line we call the reference line, this horizontal line across. Okay, now if the 0 mark, this is 1, 2, 3, 4, 5. If the 0 mark on the circular scale is below this mark, right, and we could really see the 0 on the reference line, that's on the main scale, we call this the positive 0 error. The positive 0 error. How do you figure out this? Just note that the 0 on the circular scale is always below the division on the circular scale that matches with the reference line, and we can really see the 0 on the linear or the main scale. Okay, but if it had been a negative, okay, 0 error, let's take for example that this is a negative 0 error, we won't really see the 0 on the main scale. We will not see that, okay, it will not be obvious. However, the 0, okay, on the circular scale would be above the division on the circular scale, okay? That would be above the mark on the circular scale that aligns with the reference line. So this is 1, 2, 3, 4, 5, okay? Of course, all right. So this is for this. How we'll call, and this is the negative 0 error, negative 0 error, negative 0 error. And we will have the backlash error. That's when the screw now, okay, changes its orientation. And what it simply means is this screw now is loose, okay? Like you have a loose screw, so even when you try to tighten up or loosen, okay, this pitch does not advance, okay? It doesn't move back and forth. We call that one the backlash error. Okay, so if we have a case like this, how do you really figure this out? Just note that you have to take into account the positive 0 error. In this case, this is n times the least count, n is 5, and of course if this had been in millimeter, this would be 0.01 millimeter, right? So this would be 0.05 millimeter. This is the positive 0 error. Now, in this case, this would be n times the least count, right? So this would be 95 times, if this had been in millimeter, negative implies we would not see the 0 on the main scale, it's not visible. So this is times 0.01 millimeter. So when we do that, that is, just say it is 0.95 millimeter, right? So we would always, if it's a negative 0 error, we would add this value, we would always add this value to the total reading on the main scale. And if it's positive, we will remove this value from the total reading to get the actual. Thank you for tuning in. For the sake of time, I'm going to wrap it up here. But if you're new to the channel, you want to like, share, and subscribe for more content. Thank you.